Periodic properties, intermediate public examination, CBSE board examination, for all these class 11 periodic properties, short answer type questions. Give any four characteristic properties of transition elements. Transition elements, four properties are asked here. Five are, we have given five, so you remember any four. They form mostly colored ions. If you want to give the example, say copper plus 2 blue color. They show variable oxidation states. Manganese can show plus 2, plus 4, plus 6, plus 7. They form complex and interstitial compounds. If you want to make them separate, they form complex compounds. They form interstitial compounds. 4 points are over, right? They show paramagnetism and ferromagnetism. They form alloys. This is 1 point. Another point is they act as good catalyst. Best example, iron plus molybdenum. Yes, in Haber's process. Nitrogen plus hydrogen gives rise to ammonia. In this reaction, the best catalyst is iron. This you can use here. Give the four questions are here. Give the outer orbit electronic configuration of noble gases, representative elements, transition elements, and inner transition elements. Noble gases means NS2, NP6, except helium. It is 1s2. Representative elements means all S block, P block elements except noble gases. So NS1 to 2, NP1 to 5. NS1 to 2, NS2, NP1 to 5. Transition elements will be having general electronic configuration of N-1D 1 to 10, NS1 to 2. N-1D 1 to 10, NS1 to 2. Inner transition elements means F block elements. So N-2F 1 to 14, N-1D 0 to 1, NS2. You can expect this question in 4 marks. Electron affinity of chlorine is more than that of fluorine. Explain. True, na? Actually, fluorine should be more, but chlorine is more because chlorine size is little bigger. So electronic repulsions are minimum. In fluorine, size is small, so electronic repulsions are more. So electron cannot be added easily into fluorine. Correct? See what is mentioned here. The electron affinity of chlorine is more than fluorine. Reason, in fluorine, due to small atomic size, large electron density, strong inter-electronic repulsion takes place while electron is adding. As a result, the energy released will be less, and that energy is minus 333 kilojoules per mole. This value will be different. Some books it is given 328, that's why remove that. 333 is NCERT value. Whereas in chlorine, the atomic size is large. The added electron occupies a larger region of space, and electron repulsions are much less. So electron gain enthalpy is more. Chlorine plus electron gives rise to Cl minus. Here electron affinity is minus 349 kilojoules per mole. Don't use your mathematics. Minus 333 is bigger. Minus means released. 333, 349. Just to see the magnitude. Coming to fourth question. What is lanthanide contraction? What are its consequences? Most important question it is actually. Lanthanide contraction means the steady decrease of atomic or ionic radii from left to right in lanthanides is called lanthanide contraction. Consequences: the melting and boiling points and hardness of lanthanides gradually increase. The crystal structures and other properties of lanthanides become almost same. So it is difficult to separate them from the mixture. Inert pair effect is also a consequence of lanthanide contraction. Inert pair effect, you remember, na? Lead is more stable in +2 than +4 oxidation state due to inert pair effect. Thallium +1 more stable than +3. The basic strength decreases from cerium hydroxide to lutetium hydroxide. Due to this, the atomic radius of the following elements is almost similar even though they belong to 4D and 5D series. Zirconium hafnium almost same, niobium tantalum almost same, molybdenum tungsten almost same. Generally 3D to 4D radius increases, 4D to 5D also radius should increase, but here 4D and 5D radius is almost the same. The reason is lanthanoid contraction. 4 questions are over. What is diagonal relationship? Give a pair of elements having diagonal relationship. Why do they show this relation? Diagonally related in the periodic table. Second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. This is called diagonal relation. It is called diagonal relation. It is called diagonal relation. Lithium to magnesium diagonal relation, beryllium to aluminium diagonal relation, boron to silicon diagonal relation. The first three members of second period show much similarity with second element of next group. It is termed as diagonal relationship. This phenomena is observed in first year, second year, and third year groups. Why? Because of similar electronegativity, similar radii, similar polarizing power. Okay, you can notice here. It is due to similar size of atoms or ions, similar electronegativity of the respective elements, similar polarizing power. What is polarizing power? Polarizing power is equal to ionic charge by radius square. Ionic charge by radius square is polarizing power. Write a note on next question: atomic radii, metallic radius, and covalent radius. Atomic radius. The distance between the center of the nucleus and the outermost shell of an atom is called atomic radius. Center of the nucleus to the outermost electron. This distance is atomic radius. Based on the nature of bonding, atomic radius is classified into three types. These are 1 covalent radius, 2 crystal radius, 3 van der Waals radius. Metallic radius or crystal radius is the half of the distance between the centers of the nuclei of two adjacent metal atoms in the metallic crystal is called crystal radius or metallic radius, or simply you can call atomic radius, because most of the atoms are metals. Okay, now see, there is no overlapping. They are just side by side. This distance half if you take, that is called metallic radius. Example, sodium atoms 3.72 distance, radius is 1.86. No need to by heart. If you remember, that's a good thing. Covalent radius, this is generally used for non-metals. Okay, and the half of the internuclear distance between two atoms which are held together by a covalent bond is called covalent radius. Okay, now this is not the correct image. This is not the image, sorry. This is for van der Waals attractions. Don't look at that. See here. This is the one. Now overlapping is there. This half of the distance is called covalent radius. The internuclear distance between two chlorine atoms is 1.98. Okay, now I will make this right. You see. Now you see, this is 1.98 distance. Half of this. This is 1.98. Half of this. Okay, and van der Waals radius, you see, this is AB by 2 is covalent radius, AB by 2 is covalent radius, and in one diagram only they have mentioned two. What is van der Waals radius? Actually, you should know what is van der Waals attraction. How you are going to react? Okay, how you are going to react if something happens to your brother or your sister? Fell down. Okay, now met with a small accident. Okay, now how do you react? ఒకసారి రేస్ గురం సినిమా గుర్తు తెచ్చుకోండి. అల్లు అర్జున్ పార్టీ అయిపోయేటప్పుడు, పార్టీ కన్నా ముందు ఏదో టైంలో వాళ్ళ ఫ్రెండ్స్తో మాట్లాడప్పుడు, అరే మీ అమ్మకి ఏమైనా అయిపోతుంది, ఎలా రియాక్ట్ అవుతారా అంటాడు. అమ్మా ఏదో రియాక్ట్ అవుతారు కదా, అలా అలా మనం రియాక్ట్ అవుతుంటాం కదా, అది కోవలెంట్ బాండింగ్. దాట్స్ కోవలెంట్ బాండ్. వాన్ డర్ వాల్స్ రేడియస్ అంటే, వాన్ డర్ వాల్ బాండ్ అంటే ఏంటంటే, మన పక్కింట్లోనో మన తెలిసిన వాళ్ళకు ఎవరికైనా అయిందనుకుందాం. ఫర్ ఎగ్జాంపుల్ మనం పేపర్లో, న్యూస్ పేపర్లో, వార్తల్లో వాటిలో ఇట్లా చూస్తూ ఉంటాం. ఇఫ్ సంథింగ్ హ్యాపెన్, అయ్యో ఇట్ షుడ్ నాట్ హ్యాపెన్, లైక్ దట్ విల్ ఫీల్. అంతేనా? లేదు, ఒక మంచి పని తీసుకుందాం, మీ ఇంట్లో మీ సిస్టర్దో లేకపోతే మీ కజిన్దో ఎవరిదో మ్యారేజ్ ఉంది అనుకుందాం, యూ ఎంజాయ్ లాట్. అదే సెలబ్రిటీ పెళ్ళైంది అనుకుందాం, టీవీలో చూసి ఓ బాగా చేస్తున్నారు పెళ్ళి అనుకుంటాం అంతే. అర్థమైందిగా. మనం డైరెక్ట్గా ఫీల్ అవ్వడం కోవలెంట్, దూరం నుంచి ఫీల్ అవ్వడం వాండర్వాల్స్. ఓకేనా, వాండర్వాల్స్లో ఎటువంటి అట్రాక్షన్స్ ఉండవు. Ionization energy of sodium is less than that of magnesium, but ionization energy of I2 of sodium is higher than that of magnesium. Explain. Very simple electronic configuration concept. See how you have to write. IE1 of sodium is less than that of magnesium because sodium electronic configuration is 3s1. It readily loses an electron to attain the stable octet configuration, hence IE1 is less. IE1, not IE1, IE1 is less. And magnesium electronic configuration is 3s2. It is having stable fulfilled s orbital, so it won't lose the electron easily. That's why IE1 is great. So IP1, if you see IP1 or IE1, if you see, magnesium is greater than sodium. Done. It is mentioned here. Now coming to second. After removal of one electron, sodium will become sodium plus, magnesium will become magnesium plus. The electronic configuration of sodium plus is similar to neon, which is having octet configuration. Hence, the ionization potential 2 is very high because it is noble gas configuration. Whereas in case of magnesium, after losing one electron, its electronic configuration will be similar to sodium atom. That means sodium is ready to lose the electron, so comfortably it can lose the electron. That's why ionization potential 2, if you see, ionization potential 2 is for sodium, it is greater than magnesium. Okay, don't confuse. So these are few 4 marks questions. They can be clubbed to get 8 marks questions also. 2 marks question chances are very less. CBSE and all examination there is a possibility. Okay, if you follow these notes, if you write all these points, you will get 100% marks. Okay, damn sure. You can write it somewhere. Likh lo yaar. Okay, done. Bye. Chemical bonding, next video.